And we are live. Good morning, good afternoon, good evening to everyone who joins us today. My name is Maria. You probably know me already. Happy moderator for this platform engineering webinar series. And today I'm very excited to be joined by Kaspar, the CEO and co-founder of Humanitec, who's going to talk about how to design repositories for successful platforming. You can see this amazing welcome slide from Kaspar. But before we get started, a few housekeeping notes. So this webinar will be recorded and we'll send over slides and webinar replay to everyone who registered for the session. As well as throughout the session, you can ask questions. The best way to ask questions is in the Q&A section. That way we can stack one after another. You can also ask questions in the chat or Platform Engineering Slack channel. If you're still not a part of the Platform Engineering Slack channel, you're missing out, guys. And I'll put in the link in a second for everyone to join in. Since it's the hottest community Platform Engineering, and you probably know it already if you're here. Feel free to drop in the city you're joining us from. We always like to hear from our audience since it's always very, very international. And Kaspar, you are somewhere in Berlin, or where are you joining from?
I'm joining from a little village close to Berlin that nobody has ever heard of. It's a village called Garz. You don't assume you will ever get there. Or like,
yeah, from my face expressions, I'm like, what is that? But yeah, I'm joining in from Mexico City. If anyone is in Mexico City, let's go for a drink today. And you guys can also connect after this webinar later today to, I don't know, talk all things platform engineering. But yeah, I see a lot of people from Germany. Maybe, Kaspar, you can organize something in your little event.
Yeah, please come. Like, we'll be, if like 5% of this audience comes, we'll be more people than that live in the village. So you should totally make it.
That's right.
It's like crazy to see so many people for such a dry topic. Like, honey, what are you doing today? Hey, I'm listening to a webinar that says designing repository structures to nail platform engineering. Yes, that's cool. Great. I will fantastic. Like, bring out the red wine, and a 3-digit number of people for that topic is fantastic. Good to see you.
I see, Kaspar, there is a note from Alex. Chat on the screen covers part of the presentation. Perhaps sharing mode is wrong. If yeah, because we see the screen. The chat, sorry.
Mm-hmm.
Yeah.
Oh, yeah, perfect. This way?
Okay.
Great.
Yeah, perfect. Yeah, and yeah, I guess we're ready to roll, Kaspar.
Okay, perfect. All right, we are going to, let me get this out so I can observe this here. Feel free to, ask questions. Let's make this interactive. And talk about this topic that sounds very dry, but is a very nice topic, actually. So yeah, put it on loudspeaker so your entire household can hear it. We are going to speak about designing repository structures to nail platform engineering. We want to get out of the Stone Ages, and we want to become this somewhat awkward person in the suit who looks very happy. Now, here we go. Like, why, I should swear less, why on earth should I think about repositories when I do platform engineering? Like, why does that make sense? And that is what I want to explore with you today. I believe, this might be my personal opinion, I might be the only one, but I think that actually structuring repositories is the most important thing about platform engineering, because this is really where you fine tune and you decide the level of abstraction, and you can make it really simple for developers. You can make it super hard for developers. You can make it secure. You can make it less secure. There are so many different things you can do if you structure your repositories the right way. And there is an awful lot to do of things that you can do wrong. So I I just think, and I'm also aware that I'm sometimes the only one saying that, but I think that platform engineering is about so much more than just building shiny user interfaces. I just looked at this dashboard here today. And this is actually we have an engineering intelligence thing for Humanitec's engineering team. And I was looking at this today and thought, wow, this tells me literally nothing. Like, where's the value of these three widgets here? And I looked at this while I was preparing this. And but for many, many teams, this is actually what platform engineering is about. Like, take what you have, put a shiny user interface on top. And don't get me wrong, portals have their place, very important for certain personas. But I think the real drivers of return on investment are in the repository structure. Okay, and that is what we want to explore today. Okay, and I'll go hardcore into the topic already so that we can really spend some time here. Now, this is I'm showing a worst case scenario, and I want you to think like, let's take a step back. I want you to think of a standard setup. I want you to think of what's the most common cloud native setup that I would say we see out there. It's like Amazon, EKS, containerized applications. We are doing our configurations with Helm. We have our infrastructure in Terraform, or infrastructure as code with Terraform. Or if we are hip and we've paid attention, it's now using OpenTofu. And we are using GitHub Actions for CI. We have all sorts of automation things. They have Docker containers, all of these things wired. And we are using, let's say, RDS databases, DNS with Route 53. So that's sort of the majority of our applications. And, you know, we could have the same flavor in GCP, Azure, even OpenShift, doesn't really matter. But it's the most standard setup that I would say one finds out there these days. Now, and if you then look into the majority of repository structures, at least if I'm looking at this, I might have skews in my data, then this is what I usually see. I've built this matrix. Let's see whether this makes sense. So you have an application called A all the way to your application N, and you have basically everything stuffed into that repository. And let's explore this a little bit. You have then actually one repository for the application A in environment A. You have one for application A in environment N. This is a little ridiculous because usually you just have dev, staging, and production, but maybe you have ephemeral environment, so environment A to N. And here you have application N in environment A, application N in environment N. And if we zoom into the specific repository here, we find worst case stuffed into one repository, the workload source code, the actually, this is not true. I want to, if you allow me, in this case, this is actually, so this I forgot to delete. Extremely professional live debugging here, because you actually do not find this here. You have to autocomplete this in your brain for this section here. So there is definitely no workload specification for that yet. And so here, let's make this beautiful really quickly, because I'm sure all of you enjoy watching me do this. And then if we go back in here, so we have the workload source code, we have our Docker file, we have a pipeline YAML because we're not managing this centrally, we're also stuffing this into this one. We have our Terraform file for resource A in environment B. We have our Terraform file for resource B in environment B. We have our Helm charts. And then, because for whatever reason, we have a essentially clone of this, and we do the same thing for all different environments. So in environment A and environment N, we have the same thing repeated. Cool. You might have not this or a variation of this. You might, share certain things across things. You might be reusing this. You might have a better way to set up Helm charts. What I'm showing is sort of a, politely phrased worst case scenario. Now, if you look at who's responsible for that, well, we have often a role called operations infrastructure. Some people call it DevOps, and then obviously if you say that loud, people will inform you that DevOps is not a role. Absolutely, but there's some sort of name, and they will be responsible for looking at the infrastructure and helping you with the Helm charts. And now it depends on the frankly level of either corporateness or security for how complex your world is. So if you are in a high security environment, you will have security people that review all of this before it's going out, and you'll have more guardrails, and it will be a little more difficult in the most free floating of scenarios, where one manager said like, hey, let's go, all you build it, you run it, and let's shift everything left and let the developers take care. Developers are literally just confronted with this and then somehow have to make sense of this. What's wrong with that? Well, I think we can already just see this in this picture. It's a lot of duplication. It's a lot of this being almost the same like this one, but not quite. This being almost the same like this one, but not quite. This being like a Terraform file for a Postgres. I've seen setups where you look into them and you'll see, oh, you have 250 different ways of configuring Postgres in Terraform. And that sounds really strange, because why would one assume that there are 250 ways of configuring Postgres? Like I can come up with 5 materially different ways of configuring Postgres. If I'm really creative, maybe 10, definitely not 250. But there's no different. It's not possible otherwise, because you're cloning. You're managing things on a repository by repository basis. Now, the second problem is everything is all over the place. It is really hard for developers to understand this. They need to understand Terraform. They need to understand Helm, and it does not mean that they should understand. They don't have to understand it conceptually. They have to understand it at large scale. And with these things, I often hear from people, oh, why is this a problem? And honestly, it's not a problem. Like, you don't need to have a PhD in computer science to understand Helm charts. But if you have dozens of other things that you have to do, it's just not very productive, and it's adding to your cognitive load, and you're going through value YAML files because somebody told you to update all labels and in all files, labels and annotations to the last thing, or you go to Terraform, you do this, and you look at these things. It's a deeply unproductive experience. What then happens is that the application developers ask senior colleagues. I call this that you shadow ops. You're essentially establishing parts of the team that are becoming de facto operations people. You are filing tickets to your team. It's just not great. Cool, yeah. So what are all the reasons why this sucks? Let's actually analyze this quickly. It's difficult to maintain. It's not impossible, but it's difficult to maintain. You are piling things on top of each other. You need to update. I can walk you through a couple of examples. It's just not very fun because you have to do it in so many different places. This leads to a low degree of standardization. It's like golden rule. If you don't standardize much, somebody has to actually pay the price, right? Variability is a price very often operations teams and then application developers pay. It's insecure. It's very insecure. You have very little idea how specific things are configured. Are they compliant? And you can run tests and make checkoff, boil, but there is still like an inherent risk. And we're seeing these companies that are doing like config checks and everything, and that is the fact of our repository structure is actually a result why this is necessary. It doesn't allow for specialization, and I want to cover in a second why this is a bad idea. Specialization is your friend. You should embrace the specialization and standardization. It's really hard to allow self-service in such a setup because you'll have things in dozens of different places, and it's very hard to update. So why is it hard to update? And I want to walk through a very specific scenario. why this is hard to update. Well, assume you are adding a Postgres database to an existing workload, and then you deploy all the way to production. Not a super complex thing in theory, but in every standard enterprise, that usually involves up to 3 roles: the developers, the operations and infrastructure people, and the security people. And it doesn't matter how often you shout shift left and you build it, you run it. If it's not the operations and infrastructure security people, it's, like I said, the senior developer, the principals, and they are then actually kept away from doing productive work. So de facto, you have, again, several roles that are interacting here. The developers, let's say we're in a world we already have templates, say, okay, well, let me select a baseline file to create this Postgres for my development environment. And then I can do some customizations, and then I want to make sure that this is right, and I'll send it to the operations team to review, like a pull request. They're reviewing this. Then if I'm in a high security environment, or a lot of enterprises, frankly, doesn't need to be high security, like everything that is like healthcare, finance, government, I have to verify this, and then security says, yeah, okay, this is fine, and then the developers can start executing this. Between this and this is communication, between this and this is communication. It's a little bit like a traffic jam. One person breaks and then everything gets slower. These are very often tickets, another ServiceNow thing, and it's slowing down the stuff a lot. Then we have our resource, we go into our app configs, we are adding an environment variable, we are then making sure this works, it's registers as secrets. And once we have all of that done, we repeat this for staging. And then when we have all of this done, we repeat this for production. Not very attractive. Why? Because of the repository structure. Now, let me give you another example. I want to upgrade all my Postgres instances from version 14 to 15. You can see that my progression is perfect here. Again, involves developers, operations and infra, security. Call comes in, we need to upgrade everything. We go ahead. The operations team is now going to try to understand where Postgres is running, figures out what are the teams that those workloads depend on. Then the developers work with the operations teams to update the configurations. The operations teams help them. Security checks this. Once this is approved, you repeat this. If you have 300 instances of Postgres across your estate, this will take a while. Okay, I think I've made it clear that I don't think that this is a great idea. Now, the first thing that people then do, if they, everybody sort of understands that this is not great. And then what people usually do is that they say, hey, let's build templates. And then if you're really fancy, you are putting the templates into Backstage. And that is a great idea, and it's better than not doing it. But it also means that, and why the hell have I not removed this? It still means that you have now standardized the starting point, right? Our Java template now has standardized workload source codes for start, a standardized template YAML, standardized Terraform file. That's fantastic. But 2 problems with that: it will still require heavy localization, heavy configuration to work in application A, in environment A, up to application N in environment N. It still has the same problem in updatability, maintainability, and standardization. And second, it is static to us in a second dimension, because what if you need a Java template, but you don't need DNS, you need something else, you don't need MariaDB, you need MongoDB? Well, your template will suck. Okay, so that is what's wrong. Now, my last comment here is that there is nothing in this world wrong with specialization. One of the reasons why we're doing this, or why we're following this mantra of stuffing everything into one repository and saying like, hey, one person is responsible to run this, is because we have a problem with specialization. Why do we have a problem with specialization as an industry? Because we have actually experienced a little bit of a trauma when in the early phases of programming, frankly, we have created stuff and configurations, and then threw things over the wall to operations. And then there were some operations people usually sitting in the basement that had to piecemeal stuff together and understand how A fits to B. And then and this is obviously difficult because it's also not really aligning the incentives. And then in 2008, a guy called Werner Vogels, the CTO of Amazon Web Services, said, hey, this is not a great idea. We should do, you build it, you run it. The developer should do everything. We didn't pay attention to the fact that Werner Vogels is an awfully nice guy, but had very little experience at this point, had never in his life ran an enterprise engineering team at scale. And two, Werner Vogels was speaking for a vendor, Amazon Web Services. Amazon Web Services sells more if we follow exactly this mantra. So probably something to look at a second time, And then throughout the last 14, 15 years, we've been all running into this direction of let's stuff everything into one repository and one person is responsible for all of it. So essentially, we're the only industry in the world, and since the Stone Ages, that has actually decreased their amount of specialization. And I don't think that this is a good idea. Now, platform is also because there is something we are incredibly afraid of, and that is abstraction. But abstraction does not need to be scary. Abstraction does not need to mean that the developer is restricted. Abstraction does not need to mean that you have less information than before. Abstraction does not need to mean that you're sitting around because you can't proceed or you don't understand things. That is abstraction done the wrong way. Platform engineering, we have to face that, is about doing abstraction. It's about clever, intelligent abstraction, and that also means our repository structures have to cater this. If you do not like abstraction and you think that this is how all of your repositories should look like, or very comparably, then that's totally fine. I very much respect this, but it is not platform engineering. You're just doing the normal stuff that you're doing now. And even if you put a UI on top, it doesn't make it a platform. Platform engineering is about abstraction. Now, again, I want to say this one more time. It is about great restriction, golden paths over golden pages. I keep saying this. Do not restrict users. Do not force them to use something that they don't want. Allow them to go off the golden path. Allow them to build things this way if your security posture allows. If they want this and it makes them happy, please, please, please let them do this. This is absolutely fine. But platform engineering is about covering 80% in a great way and leaving 20% of your developers to just go off and do things the way they want to do this. But for that 80%, we want to have low cognitive load. We want to have golden paths. We want to have a high degree of standardization and easy maintenance. Cool. So how do we get there? Now, the trick is really that you have to pull apart abstract requests and rules, and you need to create configurations just in time with the deployment. And I'm saying this as a prerequisite so that you understand the repository structure that I'm going to show you in just a second. If you have an abstraction, developers sending you abstract stuff, my workload is called A, it needs a Postgres and a DNS, then this is great, but you can't do anything with it. You have to first transform it. It's like writing something in Python and then sending it off into the ether and hoping that something happens. If you don't compile stuff, if you don't create zeros, translate into zeros and ones, nothing happens. So platform engineering also means we have to take that abstraction and we have to then turn it into real configurations. To do that, we need to know how to do this. So we need rules. The rules are what the platform engineering team sets. So in this example, they could say the workload should be observed by Datadog. If the environment equals staging, I should use Postgres definition N, and I want you to create new DNS entries in Cloudflare. Now, this goes through the CI pipeline and usually a platform orchestrator, and please do not see this as an advertisement for any product, an orchestrator, which is this thing that takes the abstraction and reads the rules and combines this into configurations, and actually does that job of translation, and then actually takes standardized application and infrastructure configuration and hands them over to Git, and then Argo CD and friends or another CD system can actually transform this and do the execution. Now, where are we exactly? So important to know that this has to be context aware, right? There is no one size fits all. The configuration for an environment of type development will look different to an environment of type production. The configurations for app 1 might differ from the applications for application N. And so this system has to be context aware. It has to read out the repository structure for the application side. It has to read out the repository structure for the platform side. It has to understand where am I? Aha, environment type equals staging. From the combination, it is creating app and infrastructure configurations, and then off we go. Good. So far, so good. And that means if we are, and we're getting closer, we need to pull app source code apart from platform source code. What we're seeing here is McKinsey's view on a internal developer platform. I just want you to pay attention to the version control system here. And in the version control system, we can now see that we are thinking these two things in separate boxes. There are the application source code components, and there are the platform source code components. Those are two different things. In the application source code, and we're going to go through this bit by bit, we have the workload source code, and we have the a workload specification, which is the abstract way how to describe the environment agnostic elements and basically describe your architecture in an abstract way. And then in the platform source code repository, we have our infrastructure as code. We have all sorts of automations. We have our Terraform files, crossplane files, CloudFormation files, everything that describes how the infrastructure is created. Now, let me see, where are we? This is the repository structure that we want to get to. App source code now contains the workload source code, the workload specification. We're going to deep dive on this in a second. The Docker file, pipeline YAML, although you could even move the pipeline into the platform as well if you want to reuse this. And then the platform contains all sorts of automations, deployment pipelines, maybe infrastructure as code elements, for the usual languages that we'd be using here, and then so-called resource definitions. Resource definitions tell the platform what resource how to update and create a resource based on the context plus the request of the developer. Okay. Now, the first thing that we want to look at is the workload specification. And I'm using SCORE here as an example. SCORE is an open source project that I helped build, so I'm biased. But there are others. The open application model, for instance. For Kubernetes, there's Acorn, but they all sort of work the same. So what this essentially is an abstract description of the world. We're saying, hey, I have a Python service. That Python service depends on a database of type Postgres, on a storage of type S3, and a DNS of type DNS. So what do we see here? It's very agnostic. We're not saying that particular, let's stay with an Amazon example, that particular RDS database, that particular S3, this particular Route 53 entry. No, we're just explaining in generalized environment agnostic terms how the architecture fits together. Now, this means that we can now localize this into the different environments. We can translate this, we can run SCORE Compose, and then it will be converted into Docker Compose for local consumption. And we can just send that through our CI pipeline, and then we can fuse this with the resource definitions, and we know how to create and update those different infrastructure components. So that is a workload specification. And that also means, let's take a step back, it also means that now the application source code only contains environment agnostic elements. It doesn't, like, the actual realization of the output, the actual configuration that is then being executed. You can put this into a repository for proof to make sure you have that as code, but the actual original application source code does not contain the the final, or you do not require the final configurations to already describe the application and how it behaves in all environments. And we are localizing this now to the correct environment. Now, I actually wanted to show you one more thing that I think is important to understand this. We also need to now have this component of a so-called resource definition, because a resource definition is explaining to an orchestration system how to create and update the resources. Because if we just have the abstract request here, like we do not know, like, what configs am I supposed to use? Am I supposed to create a new Postgres? Am I supposed to use an existing one? Am I supposed to update an existing one? Should that existing one be in cluster? Should it be a managed service? Like, what do you want from me? So this is what you do in a resource definition. Now, the developer request, again, workload specification. We can see here that in this case, the developer is requesting a resource database of type Postgres. And then the platform responds with a resource definition. And the first thing is that we have to ask ourselves, like, how on earth does the system know, the platform know, what resource definition to fetch? And the answer is, again, by asking what, when, and how. It's first going to ask, well, what type of resource? And you can see that this matches. Type equals Postgres is requested. Type equals Postgres is what the definition is has here. And then we need to understand, when am I supposed to use this? And this is actually what's defined in the criteria section, when to use it. When do I use that particular Postgres particular resource definition? In this case, this is a very, very narrow definition called app ID equals test app. So only if the app ID equals test app are you please using this definition. This means we have a low degree of standardization. If we want to have a high degree of standardization in your organization, which is something we always want, then we have to set the criteria to environment type equals staging, which would say, okay, every time the environment type equals staging, please use the following resource definition. Now, then we have the question, how do I create an update and delete? And this is what we usually do with drivers. And drivers are then essentially just taking certain input factors and are being executed. A driver could be a Terraform driver, could be a crossplane driver, could be a driver that's just like a little Go service that calls certain APIs in a certain way. You should be able to forward inputs to that thing, because sometimes it's not enough to just create an S3 bucket. You also want to give that S3 bucket a very specific name, like random string dot workload name dot region dot. And that is something that you can then pass on through inputs into that thing. But essentially, it could just be a Terraform template. And why is this beautiful? Because all of a sudden, our wonderful operations and security people only have to deal with one template, and they can share it across 250 workloads that will all be reusing this. So again, let's review this. This is non-trivial. The repository structure, we have our workload with the workload source code, the workload specification explaining things in an agnostic way. We have a Docker file with a pipeline YAML. Then on the platform source code, we have the resource definitions that define the what, when, and how to use a what resource IAC, resource template, resource blueprint, however you want to call it. And then we have all sorts of automations, compliance, deployment, pipeline things that can also automate things in addition inside the platform. Cool. Now we got this. Now what happens at deployment time? And this is very important. At deployment time, the system actually receives the score file every single deployment time. Also new, like there is no we're scaffolding once. It's not a fire and forget situation. Every time you are deploying, every time you do a git push, every time is a new chance to clean up, a new way of standardizing. We have our score file here, which gets sent through the CI pipeline, which hits the orchestrator. The orchestrator responds with an RMCD execution pattern, which stands for read, match, create, deploy. In the read phase, it is reading this abstract request. It's then matching the context like we just learned. Environment type equals staging. It might pull this information from the metadata. It will then pull the right baseline configurations. From that context, it will create the app and infrastructure configurations and then deploy, and our application is running. And it's doing this every single deployment, which means that if you want to change from Datadog to New Relic, you say, hey, all my workloads should now contain the following sidecar or labels and annotations. And such a system can roll this out, because we now don't have to go into 450 different repositories and click around and try to do things and call 300 different people. We just have to do it in one place and everybody's happy. Now, let's go back to our example that I used. We have an existing pain point. The developers just adds their resource. So our we want to add a resource to an existing workload, would be the right phrasing. Just the example that we were using before. And we're doing this, again, our 3 people involved. And now it's not like, hey, can I use the template? Hey, can you check this? Hey, can you security vet this? Hey, do I need to edit in the environment variables, blah, blah, blah. That's not necessary anymore. I just go into my workload specification. I add exactly those 3 lines of code. I do a git push with the context environment equals ephemeral, and I have my PR environment. I do the next git push with environment equals development. I have it in dev. I do this in production. I have it in production. Everybody's happy, operations chilling, in security chilling, and they are very happy. Now, other example is that update and maintenance example. So again, I want to update all my Postgres across my entire estate. Now this means I'm essentially updating one file. You do one call to a central system that has all of that dependency. You identify all workloads that depend on a Postgres instance. You update that one file. Security might security vet that file, and then you auto-enforce a deployment across all different workloads. And the database updates happens automatically. In reality, you would do the rollout gradually, and you would make sure that there is no error, and then there would be a way of rolling back if something happens, but you get the general idea. Okay, why does this not suck? Well, the repository structure that I showed you right now has 95% less configuration files that you need to maintain. And I can battle with anybody. If you have a system that can get the same output with 95% less configuration file and 95% variance in the input, you optimize for that system, because it is way more powerful. It's creating way more outages. It is very secure. It is way more secure. Nothing is very secure. It has a high degree of sanitization. It now allows for specialization, because the platform engineers and the operations people can focus on one thing. The developers can focus on other things. It allows for self-service. It makes it very convenient, and it is easy to update. Now, I want to say one last thing. This isn't for everybody. If you are a small team of kernel hackers, everybody loves scripts. Everybody loves infrastructure as code and value YAML files. Then this is the wrong thing for you. If you are below 50 developers, this is probably the wrong thing for you, because you just don't need it. There are like small, communication routes. You can just ask the person next to you. You're fine. Don't overcomplicate things. If you're 200 developers, if you're 2,000 developers, this is the superior architectural model, and in my opinion, absolutely necessary. Although I'm aware that this isn't used as much yet at this point in time, but it's producing fantastic results. Now, the last thing that I quickly want to look at is why, what if my developers want a configuration that is very specific and they can't get it? Like, are they now stuck? And the answer is no, they're not. Like, absolutely. Like, it's the question, they're as stuck, as you said, role-based access control. If everybody can touch every repository here, right, and you allow your developers to change resource definitions, you'll get less security, you'll get a lower degree of standardization. The more resource definitions, the less standardization, but it is totally possible in theory. And so how much standardization, how much abstraction you have is really the way how you set this up. High degree of standardization, application developers are kept out of this. Maybe like a productive thing in between, they can clone this, they can go off the golden path, you can observe them. If it makes sense, you pull in their resource definition. You might only allow this from a certain seniority level onwards. You might only allow this for that particular division. It doesn't matter. This structure, this approach does not mean you are hardcore abstracting everything away. You are just structuring things in a different, in my opinion, honestly better way. This is pretty much it. Thank you very much. And now I would love to have a heated debate with you and see what you think.
Amazing. Thank you, Kaspar. Do you want to turn off your screen sharing so that, I don't know, or bring up one of the slides? Cool. Thank you. Well, there were a lot of questions. We have someone who worked at McKinsey on the reference architecture, so which was pretty interesting. But the question that we have—
You are the real heroes.
The question that we have in the Q&A section, PG upgrade as one file update, how would you handle different maintenance windows? Postgres, I assume.
Postgres upgrade is one file update. How do you handle different maintenance? Yeah, so this is a great question. So this is what I meant. Like, reality is more complex, but if you have this type of system, you can do gradual rollouts, right? There is no reason to believe why you cannot go in and apply the same rollout principles to infrastructure that you also have in application source code. And so what we're using there is like a fleet update mechanism where you roll out on a schedule, or maybe you do like a test rollout to 5% of the estate. And if that doesn't work, then you're essentially, it's almost like a blue-green, like a canary for infrastructure rollout. And then you can test this, and if it fails, you're basically pulling back. And that is definitely, yeah, that's definitely possible. But it's a very valid concern. We have to take super serious. Like, you can't roll out to 400 Postgres instances across dozens of dependent workloads without making sure that this has a very, very thorough structure to it.
And Wilson, I know that you raised your hand. Unfortunately, everyone is in listen-only mode, but I see the question from you. So what's the structure of people, organization, org chart that enterprises would build around this product to control it centrally?
Well, so you're basically just, in my opinion, you're just changing to start treating people fairly. Like, you have these operations, infrastructure, platforms, however you call them. Like, you can rebrand them, call them platform.js, that's fine. But it's not like the actual thing that's important is that there are some people that are just specialized on being excellent at, Postgres in production, that can really deeply nerd down and say, okay, this is how you do it well, and have the time to do this, and have the time to develop the expertise, and then because what they essentially do this now, they take a little bit of time to configure this, and then they're mainly working on repeating tickets from developers. And so this is the main thing. I think it's good to product manage this. Like, I continue to be a big fan of technical product managers for platform engineering, for platform engineers. And I think there should be very technical product managers. Like, it's not about managing JavaScript engineers. It's about managing great repository structures. I'm telling you, spend your time, spend your money, having product managers structure repositories, and life is great. And that's what I would really do. Like product management is a good idea. Specialized infrastructure as code, specialized infrastructure specialists that really know the underlying systems well.
Product management, it is. Next question. It's not about rolling, but about dev team need to specify time for their app, as well as they need to specify database size, region, cache size, etc. I guess more of the comment.
That's a great comment, Alex. And actually, what you're saying is that there are some situations where developers want to configure things more deeply. And now you have actually two options. You can say, hey, we're making these parameters available in the workload specification. You could, for instance, say, I want a database of type file storage of type S3 in region US West, right? And then that actually gets passed down as parameters into the final configurations. Option number one is totally possible. Like where you set the abstraction is really left to you. Again, as long as you keep it environment agnostic, which I generally recommend. And then the second option is just to say, okay, in certain options, like what I just explained to you is not working in 100% of cases. I know that. It is working in 80% of cases, but in those 80% of cases, it works very well. And that also means that in some cases, you just have to allow them to go low level and configure everything in the exact way they want that.
Cool. How can devs pre-test database update rollout, deploy only in a dev environment first? How can the upgrade impact limited to minimum?
I mean, the answer is obviously, you already said that, that you can test this in dev first, that is representative to production by just setting basically the resource definitions to mirror the production definitions. As the more similar the production definitions are to the staging definitions, the more you are actually reducing the blast radius. That said, that's not always possible. GDPR, data, all of this. There is another thing that, to be honest, we are currently also testing, and that is simulating behavior. So you're basically simulating what happens if I now do this change, and what are the configs generated, and what are our assumptions is the impact. So yeah, I guess those are the two answers for that.
Thank you. Does this approach bring a lot of work around building the orchestrator to handle as many combinations of resources and config as possible?
I don't think so, because you do that once and you reuse it everywhere. And I mean, I think that the trick here is that you should never do. I'm not a big fan of big bang platforming, where you say like, now let's take everything we have right now and swap it into this new world. That does not go well usually. Like, I'm a fan of saying, okay, we are going to start with this application estate, do it well here. The results are so phenomenal, the other application estates will want to follow. You can also start just greenfield, say, okay, like everything we do from now on will actually follow this. And we are not going to build like 20 different templates into the blue. No, we're just responding as the demand comes. Hey, there is an application that now needs MongoDB. Oh, we don't have a MongoDB thing. Well, probably makes sense to create MongoDB for that. And like, what's great is that a lot of these big providers, MongoDB, for instance, are building their own resource definitions now. So like, hey, what's the recommended way of packaging MongoDB in staging? And that's usually open source. All of these things are coming soon, and that is already there. And that's a great way of actually dealing with that.
Nice. On a separate note, other than Backstage, if there are any other open source applications for platform engineering?
So Backstage is not an is not an application for platform engineering. It's one application that you can use for platform engineering if you want to put a user interface on top. I always say this. I really like Backstage. I love the team that works on this, but it doesn't solve any of these problems. It's literally just calling the GitHub API, and it's a JavaScript layer. Has it very important, service catalog, dashboards, everything great. But I just want to sort of make this clear. There is, for instance, Kratix that I would look at in London, Kratix. And in general, there is platformengineering.org/tooling. Is that correct, Maria? Where we can send the link. And it's like all these great tools show their capabilities integrated into this McKinsey proposed reference architecture. This is the biggest collection of resources that I'm aware of.
Look at Sergio. Sergio is faster than I am. But
thank you, Sergio.
Shared in the platform, in the chat, guys, so you can check it out.
Kubevela, check out OAM, Kubevela, Kratix. Yeah, there are a couple of good ones.
Nice. Trying to pinpoint the value of score type dynamic provisioning, is it just a way to abstract, and with any abstraction there is a reduction of file numbers to handle? So the focus on structuring repositories is in a sense focus on deciding on abstraction strategy.
That is a great way of putting it. If I would have known that sentence, I would have put it into the presentation.
Well, how do you enforce a certain repository structure? You provide a template repo and are vigilant that developers follow the rules in their repos?
Well, Sergio, this is honestly your organizational design. And there are a lot of tips and tricks on how to do this. Like the most fierce trick is just using good old rollbacks access control. There's just no otherwise. Okay, there's my little son plugging in the batteries for his electric car. I'm sure you can deal with that. So, you just say like, hey, there is no way. You need to follow the structure. Otherwise, you cannot deploy. That's the really, really harsh way of doing this. In a security-heavy environment, the question, is basically answering itself, because there is no way you could do this because security wants to vet this first. There are certain gates built in already. If you do not want to get the tough love route, then you will have to have conversations and say like, hey guys, you should use this. It makes things better for all of us. And that's a journey of communication that I'm afraid, Sergio, I can't help you with.
Well, Jorge is asking about progressive delivery, but I guess it's more of the comment to something else. Michael asking, why did you call it orchestration and not choreography, Kaspar? That's a very important question.
That is a great question. To be honest, with all of these things, at some point you are drunk and you're sitting in an office Friday evening, and you think like, how should this be called? And you say internal developer platform, and then you shout it out everywhere. And 2 years later, somebody asks like, why did you call it internal developer platform? This would be better. And you say, yeah, you know what? If you and I would have been drinking that evening, we would have called it that way. And Michael, maybe that's true for choreography as well.
Love it. Should the workload definition include the application version, for example, image tag? If yes, should the workload definition be graded as an artifact itself for deployment?
Should the workload definition be graded?
Yeah, and
treated
then,
as an artifact itself for deployment. Yeah, interesting. Yeah, so the application version image tag. Yeah, so treated. So you have the let me quickly think. You have the image tag exactly is in there, and in the deployment metadata. So that is correct, but that is in the workload definition. Yeah, exactly. And so then currently, if you're using Score, for instance, Score runs Score Helm, for instance, in the CI pipeline, and then applies this. It's actually getting it's actually passing on the path to the image, if you want, in the registry.
Cool. So do Humanitec customers get away to create the whole starter set of resources shown in that McKinsey stack slide? Those are the most commonly used, created. Sorry, not used.
No, Wilson, it is actually open sourcing. We are open sourcing this, and this is going out in 2 weeks, I think, and you can then take this and do whatever you want with it. And it could act as the starting point for your platform. We are also giving workshops on how to set these things up. Maybe we can link that as well. And you should obviously speak with McKinsey, because I know that there's a lot of negative PR around their engineering divisions at the moment with this wonderful article around engineering intelligence, but they are fantastic, really one of the best platform engineering teams I know.
Nice, and I'm putting in the link for the workshops that Kaspar mentioned in case somebody is interested. Next question, how would you overcome and enforce different building blocks versions used at application solution deployments at scale to overcome fragmentation, breaking changes more efficiently, and reducing the need for communication?
I need like 10 seconds to read this again.
Yeah, that's a long question.
Yeah. So I mean, Gabo, my answer is that is standardizing the input, standardizing the rules, standardizing the way the output gets created is my answer, especially in the area of 10,000 applications. And a strategy you can do first, the reality is that you cannot just assume that an estate of your size can suddenly be converted or migrated into this new world. That's just not going to happen. It will take too long. But what you can do is that you first register all your existing resources and one-on-one match them with the workload specification, because it's relatively simple, or it's actually very simple to write a workload specification for a workload, because essentially you're just describing this in abstract terms. So this is the first thing you do. And then for you keep you're echoing the infrastructure, you keep this as is. You are already starting to standardize that pattern where developers stay on that level. And this is and then your question, how do you overcome and enforce different version building blocks? There is actually at scale in the model that I'm showing you a similar complexity, just at a different level to what you have right now. Because the thing that will start evolving is that you have more and more and more and more resource definitions. So now we're not talking about 500 different Postgres, files. We're talking about, maybe 15, 20, but they keep growing. The good thing is that you now have a dependency graph. You know exactly that resource, what workloads depend on this resource. And that means you can also swap the resource definitions and re-standardize and re-platform much faster. I'm not sure whether that makes sense. Your question is great, makes a ton of sense. We could spend an hour on this, going really into detail how to do this at scale. Happy to do that maybe offline. But yeah, it's a very good point.
Nice. And you can message Kaspar on the Platform Engineering Slack channel, Gabor. He's there every day. Next question. Is it possible to customize the parameters specified by developers in the score file to give them a higher degree of customization? For example, create Postgres versus create Postgres plus user X plus database Y.
Yeah, absolutely. So there are parameters and classes that you can pass on. And again, how you set your, what abstraction means for you is in the eye of the beholder. You can do that however you want. You could, for instance, structure this in a way where you say, if you create an S3 bucket, the user can specify the name structure by providing variables, or you could say, you could specify the region name, or like a common thing is that you say type S3 class small, and then it's using like a small, or for S3 buckets, it's definitely like public or private. So that's totally possible, yeah. I don't want to be rude, but I have to take my little children to bed. I would love to take more questions. Please feel free to reach out to me. It looks like this is a topic that definitely resonates. We can do another session on this where we deep dive. I would encourage you to join one of the workshops. I think the next one is on the 5th of October. Maria has pasted the link. Would love to see you there. We'll probably be with my colleague Will, but he is way more eloquent than me, and so much recommended to join that. Thank you so much for staying all the time. So many of you. Have a wonderful day. Have a wonderful end of the day. I hope to see you. We hope to see you very soon.
Amazing. Thank you for doing my job to closing it out, Kaspar. Hope you guys have a great rest of the day and see you next week. Next week, we are having another webinar, as well as Kaspar already mentioned. Check out virtual hands-on labs on October 5th, which is 2 weeks, in 2 weeks.